Okay, I think most of us are good. Need to talk to each other for a while and then we are good. Okay, convergence of sequences. Some sequence converge, some series can converge, some don't converge. I think it's quite obvious. Just like GP, right? GP sum, actually there is a sum to infinity, correct? Some don't have a sum to infinity. Now this one, convergence of sequence means, let's look here. The definition is very easy. There is a limit of un as n tends to infinity. N is finite. I give a very simple example. This what is the limit? What is the limit? That means what, as n tends to infinity, the nth term will tend towards 0. Simple. This is a convergent series. Correct? Simple so far? Yes? Okay? Some series is convergent, some are not. As long as this limit exists, then it's a convergent series. As simple as that. Okay? This is the limit of the sequence. This is the limit. Okay? Now, let's do example 2. Just by looking at this recurrence relation, it is obvious that each term increases by 200. Clear cut, it increases indefinitely. Therefore, the sequence is divergent. Correct? It's divergent. It doesn't converge, obviously. Because n gets large, un gets large. There is no limit. There is no limit. Example 3. Let's look at example 3. This recurrence relation is just the negative of the previous term, which means if it starts at 1, then to be more concrete, it is 1 minus 1, 1 minus 1, 1 minus 1. Does it converge? No, it doesn't. Okay? Because as n tends to infinity, you don't know, it doesn't converge to a finite value. The keyword is a finite value. You don't know whether it's a 1 or a minus 1. So again, it's a divergent one. Okay, now we look at example 4. This recurrence relation, does it converge or does it diverge? Actually, we don't quite know. Now, can I ask all of you to take out a GC? And then we use the GC to find out. If you can go faster, go ahead and go faster. Okay, follow instructions in the notes to type in the recurrence relation. But if you are not, which I suggest you follow me, I really suggest you follow me. Alright, we can do this. Okay, can? All good? Now, first we must set the mode. Okay? Usually we will set the mode to be function here, function. Function means fx in terms of x. But now we want to set the mode to be a sequence. That means I go down, 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 enter. Okay, make sure you set to SEQ sequence. Now then we go to y equal, and you realize that your y equal screen looks different. Usually we have y1 equals to something, y2 equals to something. Now I have many things. N minimum. Let me explain each term as we go along. N minimum means because we start off with u1, correct? The first term. Usually N minimum is 1. Okay? If your first term is u20, then N minimum is 20. Follow what I'm saying? we keep this as it is. Now, I need to explain this. You see, this is un plus 1. You are to enter un in equals to something. So, first thing we need to do is, let's look here first. Let's go back to your notes. Actually, we can rewrite this. If un plus 1 equals to this, un is equals to 1 plus 1 over un minus 1 plus 1. I can rewrite this like that. I replace the n with n minus 1. These two recurrence relations are equivalent. I repeat, these two recurrence relations are equivalent. Whether you write it this way or that way, they are exactly the same. Why do I have to write it in blue? Because the GC forces us to write it like that. Correct? The GC forces us to write un in terms of un minus 1. So we write 1 plus, okay, let's do it in nice fraction, 1 over, where's my detached LCD? Here, 1 over. Now first, how do I enter un minus 1? I have to use second 7. Second 7, I repeat, second 7, not alpha 5. You highlight the thing because they both are u. Okay, not alpha 5. Because alpha 5 will also give you u, but that u is a constant. It's a memory. Okay, but this u is different. This is a variable. How do I enter subscript? I use open bracket. Okay, open bracket. And how do we enter n? You use x. You use this one that you usually enter. You use this one. Okay, Ken? Minus 1. Close bracket. Plus 1. And go down. Now you define un minimum, which means it's u1. What is u1? u1 is 0. With that, then you can use second graph to see the table of values. Make sure you can get that screen. Second graph means table. You can see the table. You scroll down a bit more. You realize that as n becomes larger and larger, it tends to a finite value. Simple enough? Simple enough? So from the GC, it converges. From the GC, it converges. What is this? Let's aim to answer this question. What is this number 1.4142? What is this number 1.4142? Of course, from the GC, you can get a non-exact value, which is 1.4142. What if you want to find the exact value? Can be like this. Okay? Can? Okay. Next part, we are trying to find the limits of the convergence series. Okay? Now, first we answer this question. What is the relation between un plus 1 and alpha? Okay, now. Oh, sorry. un should tend to the limit alpha as n tend to infinity. This is quite obvious. Let's use the, sorry, here like that. This table to tell us, as n becomes very large, 24, 25, 24,000, the un should tend to a finite value alpha. This alpha is the one that I'm interested in, 1.414. Okay, alpha is the limit of the sequence. Alright? Now, if you think about it, then actually, what about un plus 1? If un tends to alpha, un plus 1 should also be close to alpha, right? Should actually be even closer to alpha. Correct? Need to copy. Should be even closer to alpha. So, un plus 1 should also tend to alpha as n tend to infinity. 2. Make sense? If un tends to alpha as n tends to infinity, un plus 1 should tend to alpha as well. Makes perfect sense. Let's use this table to help us to be a bit more concrete. Now it's only 24. If you go on and on, if 24 is close to the value alpha, u25 should be closer to alpha as well. Follow? It should tend closer and closer to alpha. So we make use of this idea. I promise you I'll give you a mental break after example 5. Okay? Okay, I know it's a bit exhausting. My point is, the sequence should converge to alpha, and how are we going to find alpha? I am making use of this idea. Let's use the same recurrence relation, okay, example 5. Okay, I need your fullest attention. We must understand the highlighted bit, okay? See, as n tends to infinity, un, if the limit exists, should tend to alpha, which is the limit. Un plus 1 should also tend towards the limit. Correct? Makes sense. So, if we substitute alpha into here and here, we can solve for alpha. Follow what I'm saying? That means as n tend to infinity, this is alpha. As n tend to infinity, this is also alpha. This is the most important step. As n tends to infinity, un plus 1 is close to alpha. Un also close to alpha. I use this equation to solve algebraically for alpha. Not too bad, right? Not a difficult equation to solve. So the rest is easy. All I need to do is to say I minus 1 on both sides. Alright. Then I multiply both sides by alpha plus 1. I get alpha square minus 1 equals to 1. Then I get alpha square equals to 2. Alpha equals to plus minus root 2. Now at this point, we cannot accept two values. So we better write plus minus 2 first, and then we see which one is valid. There are many ways to do this, okay? First way is if we take a look at this recurrence relation here. We start off with looking at this. There's no negative sign. I repeat, there are no negative signs. And the first term is also not negative, it's just 0. There's no way the next few terms will ever be negative, because there are no negative signs. So by logic, we can see that is what we mean by this. From the given recurrence relation, the terms are non-negative, therefore you can reject negative root 2, therefore alpha is root 2. Actually, the second way is this. Turn off already. The second way is this. By GC, if you enter the recurrence relation in your GC, you should see a number that actually UN tends closer and closer to as n gets larger. And this number is a positive number. So you can actually say by GC, reject negative root 2, accept root 2. Just by GC. So there are two ways. Okay. Before we go to example 6, let's take a 2 minutes break.